Yeah, we are welcome back to solving initial value problem using the Laplace transform method. Okay, and we have the differential equation, and this one is non-homogeneous second order differential equation. So, how do you solve it? How do you use Laplace transform to solve non-homogeneous second order differential equation? Okay, without wasting time, the first thing we do is to take the Laplace of both sides of the equation. Laplace of second differential is this. So that's the Laplace of second differential. This one is minus 7, open bracket. Laplace of first differential is this. Okay, then plus this thing is a constant, then plus 10 times Laplace of y. Okay, equal to Laplace of cosine, that will be 9 times x over x squared. The attachment to t here is 1 plus 1 squared. Then plus 7 is a constant times the attachment to t here is 1 over x squared plus 1. Laplace of this is this. Then the next thing to do is to begin to substitute the data given. I mean this one, okay, the initial value. So this is 5. This one is a minus 4. This is a 5. Okay. Then we can factorize this. The Laplace is here. The Laplace is here. The Laplace is here. So we have x squared minus 7 times this. That's 7x. Then plus 10. Laplace of what? Laplace of y. Then here we have 5 here times this. Minus 5x. Then this is minus 4 times minus, that's plus 4. And here we have minus 7 times 5, that's a plus 35, equal to this time and this, that's 9x over s squared plus 1 plus 7 over s squared. So we now have this s squared minus 7x plus 10, Laplace of this equal to 9x over this plus 1 this over this plus 7 over this one, then plus 5x, and then plus 4 plus 35, that's a plus 39. We can move it to the other side, so minus 39. So we now have this s squared and 7x plus 10, Laplace of y equal to this over this, then plus 7 over this one. Then we can move this one to the other side. 4 plus 35, that's 39. Can also go to the other side. So that will be plus 5x minus 39. So that's what we have. Then we can make this Laplace the subject. And that will be this equal to 9x over s squared plus 1 times this quadratic expression, then plus 7 over s squared plus 1 times this quadratic expression, then plus 5x over this quadratic expression, then minus 39 over s squared minus 7x is 10. Okay, so that's what we have now. You can find the SCM of the right hand side. So the right hand side, we now have the LCM So the highest common factor is this s squared plus 1 over s squared minus 7x plus 10. That's the highest common factor. Okay? So if you do that, here, for this factor here, it will remain what here? It will remain this. Okay? I'm taking the LCM of the right hand side. Then plus, it will be 7. This we cancel. Then I have 5x times what? Times s squared plus 1. Then the last fraction here, this one also, and this one we cancel. I have minus 39 times this one, s squared plus 1. Okay? Then we can open these brackets. Then we have this one plus 7. This one times this one, as a 5x cubed plus 5x. This one times this, minus 39, s squared minus 39, all over this, over this, this times this. This one, we can start arranging. That will be equal to, according to the power, this power 3, that's 5s cubed, followed by minus 39 s squared, and followed by 5 plus 9, that's 14 s. Okay, this is minus 39 plus 7, that's minus 32, all over what? The common factor, s squared plus 1 times x squared minus 7x plus 10. Okay? Then the next thing to do now, if you look at this quadratic, I think you can factorize this. You can factorize this, and that will give us what? This one, pair that, one here, one here. Factors of 10, they can give us minus 7. That would be minus 5, minus 2. And minus 5 times minus 2, that would be 10. Okay, so we can now write this as what? We can now write this as, we're going to take the inverse of this. The inverse of this function will give you this. Transforming from s domain to what? To t domain, to time domain. Okay, so the moment you take this, this Laplace, inverse Laplace of this, you have this as a function of t equal to inverse Laplace of this expression, which we are looking for. So, and if you check your denominator is having power 4, which is higher than numerator, and this will take us to what? Partial fraction. We are looking for the inverse of this expression. Okay, there is no table for this expression. We need to break it down, okay, to sum of functions using partial fraction. So we can write this this fraction, this expression. We can write this one. Write this one. Let's take it out. This is this minus 39x squared plus 14x minus 32 all over x minus 5, x minus 2, and s squared plus 1. Okay, and this will be equal to these two, their linear factor. So it's going to be a over the first linear factor, s minus 5, followed by b over x minus 2, followed by, this one is a quadratic, and that will be equal to what? That will be equal to, your constant is stop at b here, so the next one will be c, x, and then plus another constant d, all over x squared plus 1. Okay? So then multiply through by the common factor by this expression. So if you do that, on the left side, you have this. On the right hand side, you're going to have a, this one, times the common factor, and that will be what? A times this plus b times the common factor, and that will be what? X minus 5. X minus 5 times s squared plus 1. Then your c, this one, this fraction times the common factor, this we cancel, and we have what? X minus 5, x minus 2. Okay, so that's what we have now, and that's what we have now is to find a value for A, B, C, and D. So based on the expression we have here now, what we'll do is use substitution. Okay, we can make S to be 2. If we do that, this expression we cancel, this expression we cancel, that is 2 minus 2. So this we cancel, then we can get our B. Okay, 32. So this is this left side is minus 120 equal to. Let's substitute here. So which will be B times 2 minus 5, that's minus 3. And then 2 squared plus 1, that is what? That is 5. Okay, so we're having now B is equal to minus 120 over minus 15. I think that will be 8. Let's check that. That will be 8. Yeah, so B is what? B is 8. We can also check again. We can also try let x be equal to 5. If we do that, this expression we cancel, this we cancel, we can get this. So let's do that. For the left side, we have a minus 312 on the left equal to here, that'll be A, 5 minus 2, that's 3, and here, that's 5 squared plus 1, that's 26, minus 312 equal to 78, A, so A is what? Minus 312 over 78, minus 4, is minus 4. So we've gotten A, we've gotten B. So what other value we can use for substitutions? We've already used 2, we use 5. Let x be equal to 0. If it's that, then we have minus 32 on the left equal to, on the right, we're going to have A into times minus 2 followed by 1 and plus B. This will be minus 5 followed by 1 also, and plus, yeah, this one we cancel, C times X we cancel, we have B, we have this D times minus 5 and then minus 2. Okay, so we have minus 32 equal to, our A is, we do have A value, we have minus 4, so minus 4 times minus 4 times minus 2. Okay, then B is what? 8 times minus 5, and that's what? Plus 10D. So we're going to have minus 32. This is this one times this one, that's 8, take it to the other side, becoming negative. This is minus 40, take it to the other side, that's plus 40, got to 10D. So this one is 0, so D is what? D is 0. Then the next value we can try 1, then try minus 2. Let x be 1. We have a minus 52 on that, on the left side. Okay. Then we have A into bracket 1 minus this, that's minus 1. Then it will be 2 plus B. This will be 1 minus 5 minus 4. And this will be 2. Then plus. This is what? D is 0, so this is gone. I just have what? C into bracket 1 minus 5 minus 4. Then 1 minus 2, that's minus 1. So I have minus 52 equal to this one times this one, that's minus 2. My A is what? Minus 4 plus. My B is what? B is 8 times minus 8. Minus 4 times 2, that's minus 8. Then plus 4, minus 4 times minus 1, that's 4, that's 4C. That's 4C. So I'm having minus 52. I can move this one to the other side. This is a plus 8, that's minus 8. This is minus 64, that'll be plus 64. Because what? 4C. So this is 4 here, because what? 4C. So C is what? C is 1. Okay? Don't forget that this fraction here represents what? Represents this. Okay? So we can take inverse of that equal to. Once we take the inverse of this, that means we are taking the inverse of the right hand side, which is equal to A is what? Minus 4 over this. Then followed by B is what? 8 over this. Followed by D is 0. And then C is 1. So we just have plus x over x squared plus 1. Okay? And close the brackets. Okay? So the final conclusion will be this one without wasting time. You can take this one outside the Laplace, minus 4. And the Laplace of 1 over, that will be this one, 1 over, that's Laplace of this. Here also, that will be plus 8, inverse Laplace of this. Then the last one, inverse Laplace of x squared plus 1. So on the final conclusion, you just have this one minus 4. Inverse of this, inverse Laplace of this will be exponential to power 5t. Okay, and then plus this one will be 8 exponential to power 2t. And this one is a straight table, that will just be what? Plus what? That will be plus cos t. And that finish the question. The tools that we use here is a partial fraction. Okay, you must know how to solve your partial fraction that involve quadratic. There are like 6 or 7, 6 thereabout videos on this channel. So check the video on partial fraction. Everything you need to know on partial fraction on that video as we explained. Just look for that video on this channel. Okay? And I'm also trying to put the links of those videos. So please, if you are new on this channel and you are yet to subscribe, the icon is to this side. Click on the icon on the video and subscribe so that you can keep track of the beautiful updates of this channel. Okay? And begin to type your comments. Make this section interactive. Type your comments and click on the like button. And most importantly, share this video on your social media platform. Okay? Begin to share it now. Thank you for doing that.